Hey guys, we're going to look at how to determine if values on a table are linear functions or exponential functions. So we talked about this already a little bit. Linear functions basically are repeated adding, whereas exponential functions are repeated multiplying. So when you have that repeated adding, we call it the slope or rate of change, and they call it the base or multiplying factor in an exponential function. So what you want to do is determine based on how the table changes if it's repeated addition or repeated multiplication. So in the case of this first table, we are increasing by 1 in the x values, but the y values are where the information is going to be that we need. So in this case, I go from 5 to 10 to 20 to 40 to 80. Now if I add 5 to 5, I get 10, but if I add 5 to 10, I don't get 20, I would get 15. So that's going to lead me to believe that it's multiplying. So in the case of what could I multiply by? Well, 5 times 2. And then if I can do that same multiplying the next time, times 2, times 2, times 2. Feel free to put x's either if you want for times 2, but we usually don't use x, that multiplication x anymore. But as for this one, it's fine. So table 1, this is going to be our exponential function. And then table 2, 8 plus what will give you 11? Well, in this case, it's 3. And then if I continue that addition, I get each following number. So for exercise 2, they want us to find equations in standard form. So for the exponential one, we're going to use this form, where we got a, our base value, or multiplying factor, and x is our exponent. And for this one, we're going to use mx plus b for our slope and y-intercept. So for the first one, I see that the y-intercept is 0, 5. So I know 5 is going to go first. And then I'm multiplying each time by 2, so that's going to go in the parentheses with my x outside it. And then with the linear function, well, we know the slope is 3, so it's going to be 3x. And the y-intercept is when x is 0, so in that case, it's going to be plus 8. So you want to determine the pattern. Look for the pattern and determine if it's repeated addition or repeated multiplying. Now we're going to look at exercise 3, and they want us to create a linear equation that passes through the points in our y equals mx plus b form, and they want us to do an exponential equation that passes through those points. So we're going to go ahead first, start with the linear. So I want to figure my rate of change. So in the case of this, if I subtract these two, I get 9 and negative 1. So that would mean my slope would be equal to 9 divided by negative 1, which would just equal negative 9. So that's my m value, negative 9. So our equation for this would be y equals negative 9x plus 12. So there's our linear equation. Now the next part asks for the exponential equation. So again, we're going to use this form, the one they put up here. Now we know that in the case of this one, we have 0, 12, so that's our y-intercept 12. Now if we want to find that b value, what we're going to have to do is we're going to have to divide the 3 by the 12. We know it's repeated multiplication. So in this case, if you take the value, the 3 that we had for the first y value, and divide it by the 12, that's going to show the decrease, and in that case it'd be 0.25. So I can call this 0.25 in here, or you could put it as 1/4. So kind of like we subtract to find the average rate of change and our slope. If I want to find that multiplying factor, I can use the opposite and divide the y values to find that multiplying factor. Now, in the case of the graph, and again, we're just kind of talking about a couple of the points. I mean, you can kind of figure out where it says do negative 2 and 2 for the x values. And then it says -5 to 15 for y values. So I'm just estimating these. So I got 0, 12, which would be here, about. And then we got 1, 3, which would be about here. Now again, the linear is going to be straight. So the linear one I'll draw first. The linear one is going to go through those points and stay straight. That's my linear function. And the exponential one is going to come down and curve and go along that x-axis. Okay, so this is our exponential, 12, parentheses 0.25 to the x, and then the other one is our y equals -9x plus 12. So you can clearly see with that repeated addition, your slope's going to be consistent, the line's going to be straight. But then when we get the exponential function, it's going to kind of level out, because you're going to see the numbers in the table get smaller and smaller, but not cross the x-axis. So y is still greater than 0. So, like we talked about earlier, just to recap, look at the top. We talked about what type of function and the pattern that it shows. And then also, if you have to graph any of these, make sure you look for that y-intercept like we talked about, and also the pattern. So is it multiplying by or adding by to get the next ones?